Actually, we missed to implement print in reverse function, which means the function will print our linked list elements in reverse order using a recursion using recursive function or using recursion. Okay, let's see how we can implement it. So in order to reverse a linked list, we will use a recursion function, and the time complexity would be on. It can be coded with two steps. Write the unit task with condition to return, and then else call the function itself. We will see what does all this mean. So unit function means for a recursion, to exit from a recursion function, you will have to write a unit condition. So when the unit condition is met, you basically return. Okay. And our return condition is if head equal to none, return, which means we don't have to do anything with our list. We have reached the end of the list. And if you don't reach this condition, call the function and again and print. So all the print command to print the linked list will print recursively, because all the execution of print will take place after all the recursive functions are stacked out. We will see what that means in a bit. Just remember that the print, we will print element after we call the recursive we call the function itself. When the function will stack one by one after returning from the unit condition, that's the order all the elements of our linked list will print. We'll see what we mean by all this complex statement. Again, we will define a new function. This function, if you want, you can define inside the class, but for now we will define it outside the class, and we will name it recursive display reverse head. Since we can't pass the whole list to it, we'll just pass the head information. If head equal none, which means we have just reached the end and we have nothing to do, we'll just return. Else we will do our thing. We will call the function print head.data. See, anything will pass through this function as head. When we call it, we will call it through our linked list head. So again, whenever we recursively call this function, we will say that we are passing head.next, but this head.next is accepted in the function as head. This is so simple. We will see how we can do it. ll dot recursive, no, sorry, we can't call it this way. We'll have to call it like recursive display reverse ll.head. Okay, run it. Oh, it's been it's being printed recursively. Okay, 2, 9, and 11. It's interesting, right? What's happening? So when these are all stacked, like first call stack it with like just I'm doing. So our list, remember our list was 2, 9, 11. Okay, so what we pass as information to it here, 2. 2 is not none, so we will recursively call our function again with 9. Okay, so this one is actually, this call is actually stored. Like we can say RDR, recursive display reverse. It's stored and then RDR 9, and then it's stored RDR 11, and then it's stored what? RDR none. Okay, because the last element is pointing to none. So when we reach this condition, we basically return. But then these calls are actually stacked. Okay, then after this call, this one runs, but this one has nothing to return, so just this prints the data. It's data. Okay, this one's data is printed here. Then again this one runs, this call runs, and then this data is printed, and then this call runs and this data is printed. So this is the technique going on. While we want to reverse display a list. The next function we will implement is get node value, where our input would be head and position from tail. Okay, if our linked list is like 6 elements tall, then we will take a position from 0 to 5, but that will be the position from starting from the tail, last one. Okay, let's see how we can implement this function. This is actually pretty simple. So what we will do, the as input will have head position and position from tail. The complexity would be O(n) because we'll have to traverse through the linked list. Get the length O(n). We'll have to first get what's the full length of the list, and then if we subtract the index we are given from the length, then we will get the position from the head. And this -1 is for, since our in Python the index starts from 0, so we will have to minus this position and get to the index. Since we now, this index is now our position from head, so as usual we will get to the index and return the node value, and that's pretty simple. Let's see how we can implement this. Again, we will define inside the class get node value self. Since this function is inside the class, we need self and the idx. This is, remember, this is position from tail. First we'll have to get the length, right, as we saw before. Current node is equal head node, not equal, sorry, assign current node as self head node, and then first our len 0 as we traverse, while current node is not equal none, len assign len +1. So we got our length. Now our next thing would be calculate index from starting or head. It's pretty simple, as we saw. idx is equal to len minus idx minus 1. And then just get to the node, return the value. We need another variable, I is equal I assign 0, while current node I'm sorry, actually here I forgot to write the forwarding condition, moving condition, okay? While current node, I do a lot of printing mistake. While current node, if hmm, hmm, we have to again assign current node as our head node. Return current node dot data. If we get to the index, then return the value, else current node assign, just move forward, current node dot next. Okay, now this is our list, if you remember. And if we say that ll dot, what was the function name again? Get node value. Okay, get node value. So if we want to, from tail, we want to see number 1. Okay, then we will just pass number 1 and then ll dot display. For now, we just stop this function and let's run whether we get our desired 9. Okay. No, no, I'm sorry. Okay, this is not the thing. You just have to print what you get from here. You have to see whether we get 9. And we got actually none, which means we're mistaken. Let's see where we're mistaken. I think the mistake is I haven't updated this I value, okay? Whenever, because I have to match the index with IDX. Sorry, this is another mistake because IDX is the index from starting from tail. Now our latest index is starting from head, so we'll have to match with the index starting from head. Okay, we'll have to update the I value because this will find which one is our index, as well as the current node will be updated to its next value, and then we will find it. Let's run again and see. So we want to know what's the value at our index number 1 starting from tail 0, 1. So we want to know 9 is the value, but I don't know why it's printing 3 now. Let's run it from this time. For some reason, cell was not working, but now it's successfully returning the value 9. Now we will check what if we give it 2, like from tail we want to see what is in the number 2 index, which is we want to see 11. Let's see whether it works or not. Yeah, it does. Okay, so that's it. Next we will go to cycle detection problem.